Good afternoon. I'm Dr. P. Usharani, Professor EEE SNH Department, RMD Engineering College. I'm going to brief about the topic of CE configuration of transistor, minimum base current requirement. I've taken common emitter configuration, output characteristics of transistor. If you take care of this, you have drawn the graph between VCE versus IC collector current. Here if there is a slight increase in my alpha, means there is a slight change in my beta. How this happened, if you take care of this, means using the formula of beta as alpha by 1 minus alpha and collector current as 1 plus beta into ICBO plus beta IB. If for example I have taken alpha value as 0.98, I am substituting in this formula alpha divided by 1 minus alpha. So if I substitute, I am getting beta value as 49. Now next step, I am just increasing slightly alpha value from 0.98 to 0.985. So if I use the same formula alpha by 1 minus alpha, I am getting 66. So what's the inference here as there is a slight increase in alpha by about 0.5 percentage. This results as increase in beta by about 34%. So what we infer from this example as the output characteristics shows a larger slope, okay, a larger slope when compared to common base configuration. That is the inference from this equation we inferred, okay. Larger slope when compared to CB configuration. And just a recap of the three operating regions, that is three regions for transistor operation. Saturation as a Hatched region, both junctions are forward biased, okay. That is junction emitter base as well as common collector base junctions are forward biased condition. So increase in IB value, okay, increase in IB value, this does not cause a corresponding large current. So which one we are saying as saturation region as to the left of the line OA. Line OA is named as saturation line. Below this left half of the portion we are saying that is saturation region, okay. Cutoff region is below the curve for IB as 0, okay. This is IB 0 line, below this as known as cutoff region. Here both the junctions are reverse biased, that means the transistor is off condition, okay. Now your collector current is 0, collector voltage equal to VCC, that means transistor is virtually an open circuit between the collector and emitter, that is for cutoff region. Third one is active region, this portion is active region, okay. The curves are uniformly spaced and the slope, already I have mentioned, slope is large when compared to common base configuration because of the increase in alpha. We have shown 34% increase in beta, that's why we are getting large slope. So here EB junction is forward biased and the CB junction is reverse biased. The transistor is said to be linear amplifier, okay. So we can say this is the basic three regions of transistor. Here we can say the transistor is a short circuit condition also, unhatched active region. So I have taken one example of how to find out minimum base current required in order that the transistor enter into saturation region. For that I have taken the example of the problem which I have shown in the diagram. So they have mentioned alpha value as 0.98, ICEO they have given, VCC value 12 volt, RC value as 4 kilo ohms. For this problem, we have to find out minimum base current required. So for that, using this formula of IC saturation divided by beta. Beta has current gain which is always larger when compared to, that is the one of the advantage in common emitter, high voltage gain, high medium current gain. So power is high. Due to that only always common emitter is preferred. So if you want to calculate beta, we have to use the formula of alpha divided by 1 minus alpha, and IC saturation as if you apply based on the circuit, okay, we can find collector current saturation state, that is VCC divided by RC. So we can calculate ICC using this formula, IC saturation and beta, and we can substitute here IB minimum, we can calculate using this formula. Now these are the given data we have considered, and the first step I have to find out IC saturation, which is VCC divided by RC. I have substituted the values of 12 volt divided by RC value is 4 kilo ohm, so 4 into 10 power 3, which is answer as 3 milliamps. Now next step I am substituting alpha value for calculation of beta. So alpha is 0.98 divided by 1 minus alpha, 1 minus 0.98, I am getting 49. And minimum base current requirement as IC saturation divided by beta. So our calculated value of IC saturation is 3 milliamps, 3 into 10 power minus 3 divided by 49 beta value. If you substituted, the answer is 61.224 microamps. Thank you.